Hello everyone. I am Pallavi and my friend Srinu. We are
Hello everyone, I am Srinu.
we both are from SRM University. Today we are here to present our project titled Washing Machine Simulation using PICSIMLAB. This was a team effort completed by two of us during our embedded system internship. Together we worked on design, coding and simulating a virtual washing machine using the PIC16F877A microcontroller. This project was part of our embedded system internship where we worked as a team of two under the guidance of Guru Priya. She helped us understand both the theory and practical sides of embedded design. Our goal was to simulate a working washing machine using PICSIMLAB and MPLAB tools. Working as a team allowed us to divide the task efficiently. For example, one of us focused more on the coding and logic, while the other worked on simulation setup and testing. Before explaining our project, let's first understand what an embedded system is. An embedded system is a dedicated computer designed to perform specific task as a part of a larger device. Common examples are washing machine, microwaves, elevators, and fitness trackers. At the heart of this system is the microcontroller, a small chip that contains the processor, memory, and I/O ports in one unit. Our objective was to design a program and simulate an automatic washing machine using PIC16F877A microcontroller. The system had to handle multiple operations were wash, rinse, and spin dry, controlled by user inputs to a keypad and displaying status on an LCD. As a team, we used tools for our project: PICSIMLAB for simulation, MPLAB IDE for code development, XC8 compiler for compiling our C programs. We divide our tasks so that one member focused on writing and debugging code, while the other member handles simulation and testing to ensure hardware behavior matches our logic. We have also learned C programming, microcontroller basics, PIC16F877A microcontrollers, LED interfacing, DKP board, MPLAB IDE, and simulator tools. So, C programming, we learn how to write code in C for microcontroller based applications. This helps us understand how to control hardware using software, such as turning LEDs on and off with logic. Microcontroller basics. We understood the concept of microcontroller, a small chip that acts like a mini computer. It takes input, processes it, and gives output to control external devices. Pick 16F877A. This is a microcontroller with 40 pins. It can be programmed using C and is commonly used in embedded systems. It supports digital I/O timers and serial communication. LED interfacing. We learned how to connect LEDs to the microcontroller and control them through C programming. This involved using GPIO pins to turn devices on and off using code. DKP, digital keypad board. This is a development board that allowed us to interface input devices like keypads with the microcontroller and write code to handle their inputs. MPLAB IDE and simulation tools. We use MPLAB IDE for writing and debugging code and simulation tools to test the programs virtually before developing them on actual hardware.
And develop a mini automatic washing machine system using the PIC16F877A microcontroller, which automates wash, unish, and spin cycles through keypad input and relay controls. The system overview. The project simulates automatic washing machine system using a PIC16F877A microcontroller. The user interacts with the system through a keypad, selecting the modes and water levels. A door sensor ensures safety for pausing operation if the door is open. These microcontrollers output device like the LCD buzzer, fan, and simulated motor. All operations, wash and spin, are automated and displayed in the real time on the display LCD. And development and testing carry out entirely in a virtual environment using MPLAB, XIDE, and PICSIMLAB. The tools are used PICSIMLAB, MPLAB, IDE, XE8, compiler, and timer and keyboard. And this is the flowchart of the overall tools are used. And peripherals in design. PIC 16F877A are used for the core controller managing all system operations. The 16 to 2 LCD display displays system status, modes, and timer values. Um, the keypad allows user inputs for selecting modes and starting stopping cycles. Relay modules control simulated motor and heater operations. Fan simulates the drum spinning during wash or spin cycles. Door sensor ensures safety the detecting if the washing machine door is closed. Buzzer provides alert during the system events like cycle completion. Hmm, the key observations. The project is fully simulated in the virtual environment using PICSIMLAB and MPLAB IDE. No physical washing machine hardware required. The switch 5 we are using starts the washing machine process and initiating fan rotation visible in the simulation, and switch 5 to stop the washing machine process, and switch 1 simulates the door sensor preventing operation when the door is open. And real time system feedback is displayed on the LCD display. And then let's coming to the project demo. During the demo, you will observe mostly system startup on the PICSIMLAB interface and mode and water level selection in the VIA keyboard, door status checking using the simulated switch, and LCD displaying washing machine progress, and fan simulation representing rotation during washing and spin, and buzzer alerting at the cycle completion. Let us come to the result. The project successfully demonstrate has a how a microcontroller can control and automate the household applicants like a washing machine. All major operations wash, rinse, spin, user input handling, safety checks, and status display are implemented using embedded C. The system functions exactly as intended within the simulated environment, providing a safe, controlled, and educational experience. And let us come to the conclusion. This project has provided practical hands-on experience with the microcontroller programming, peripheral interfacing, and real-time embedded system design. We successfully designed, developed, and simulated on the automatic washing machine using the PIC 16F877A microcontroller, all tested virtually without physical hardware. Through this, we enhanced our understanding of the embedded systems, user interface, and system control logic.